Welcome, ladies and gentlemen. Yesterday we were talking about angle measure and radians being a new way of measuring angles. And here's a problem from last night's homework on page 348. Problem 33 is indicated by this 33 and then a point. That's not a decimal point because I don't think there's a... Actually, why do they have like 33A instead of like 33.1 and 2 and 10 or something like that? Yeah. Well, nonetheless. So one of the things I'm going to do is I would recommend figuring out where on Earth this angle is. Specifically, which quadrant. Which of the four corners of the Earth is this dwelling? So, negative 19 pi over 6. So let's see. So first of all, it's moving clockwise. So this would be... how many pi would this be? 1 full pi, right? So here's 2 pi, right? Now, if I'm measuring in pi's over 6's, this would be 6 pi over 6, right? And then 12 pi over 6, all right? And then do I have enough room for another full pi?
Yeah.
So 12 pi plus another 6 pi would be 18 pi over 6, and then it looks like I'm landing right here. Okay? Is where I'm at. So this is negative 19 pi over 6. The other way I could have done that is to find a coterminal angle to it. I'll do this in blue, actually. I could have taken negative 19 pi over 6, and one full revolution, right? Normally we found our coterminal angles by adding 360 or subtracting 360. In this case, I'm going to add 2 pi to this until I'm awesome. And in order to do that, I'd have to multiply this by 6 over 6, right? To get a common denominator, which is the 12 pi is 1 full, 12 pi over 6 is 1 full revolution that I talked about a moment ago. So this would have been negative 19 pi over 6 plus 12 pi over 6, right? Which would have been negative 7 pi over 6. And then if I'm like, well, negative 7 pi over 6, by the way, would have been this right there. But I still want a different coterminal angle to that. I could have actually added 2 pi to that again, or added just the 12 pi over 6 to it again until I get a positive one. And this would then give me 5 pi over 6 is the coterminal to that. All right? So 5 pi over 6, which angle on this is 5 pi over 6? I don't believe any of those labeled angles are. 5 pi over 6 would have been this direction, right? So there's 5 pi over 6. But that's still, well, actually, let's write it all out, I suppose. So cosine of negative 19 pi over 6 is the same as cosine of 5 pi over 6, right? That all I've done is gotten rid of I've boiled it down to a coterminal angle that's within 0 to 2 pi. So now I'm going to find the reference angle and figure out whether or not cosine is positive or negative. So in this quadrant, what is cosine?
Negative.
Right, because cosine is positive here, negative here, positive there. So cosine is negative in that quadrant, and the reference angle would be how much in radians? Well, I could find out for sure. This is quadrant 2, so I'd want to subtract it from this location. What is this full amount?
Pi.
That's a pi radians, right? So that would be 6 pi over 6 minus 5 pi over 6 is going to give me pi over 6 as the reference angle. All right? So there's my pi over 6. And, as I said a moment ago, cosine is negative in that quadrant. So that's the same as negative cosine of pi over 6, right? So equals. Now, cosine of pi over 6, let me see if I can hand trick it. All right. Actually, labeling my fingers. This would be 0. This would be pi over 6. This is pi over 4. This is pi over 3. And this is pi over 2.
Can you go over those numbers again?
Yep. 0.
Yep.
Pi over 6.
Yep.
Pi over 4.
Yep.
Pi over 3.
Yep.
Pi over 2. All right?
Why don't you go backwards? So
Because pi over 6 is smaller than pi over 4, right?
Oh,
Dividing something into
yeah.
6 parts would be smaller than... Right? But yeah, it takes a little while to get used to because we're so used to our 0, 30, 45, 60, 90. So to find cosine of pi over 6, I'm going to put my pi over 6 finger down, and cosine will be the square root of the fingers to the right divided by 2. So root 3 over 2. So this is going to be negative square root of 3 over 2. So I just want to point out, all of that work can still be done in the realm of a radian measure rather than degrees. Now, chances are last night what you guys probably would have done was just converted that to degrees and then done the whole problem. And that's fine. But I do want to get you kind of into the habit of thinking of radians, knowing these angles from, in radian mode, and just kind of being familiar with those. So other questions from the text? Someone said 35 or something like that?
Yeah. 35 to 45. Anything.
35, it says, given the measurements of a central angle, find the length of its intercepted arc in a circle of radius 14 centimeters. Meh. Here we go. And for 35, 5 pi over 12 is the value. So I've got a circle. The radius is 14 centimeters. Right? And the angle is 5 pi over 12. Where would that be? All the way over here would be 12 pi over 12. This would be 6 pi over 12, right? So 5 pi over 12 must be like this.
yes, I agree.
All right? Because think about the way I figured that out was thought of the full pi, which of course is only half of the circle, and then dividing it up into 12ths, which would be like dividing this, and then dividing this up into 6ths, which would be, and then, yeah,
I think you could fit one more in there.
ish, okay. But yeah, 5 pi over 12 is almost a pi over 2. All right, so the more familiar we are with fractions, the better we
Now I
will
kind
be.
of want some pi.
Yeah. Actually, someone wrote a code up on the board over there. They said the square root of -1, 2 cubed, sigma, pi.
What does that mean?
I want to eat pie.
I ate some pie.
Dang, I was close.
Right? I don't know. Thought that was interesting. Sigma, right? Greek letter S signifies sum.
Oh,
We used that back in Excel as well. Good stuff. So, anyways, if I want to find what do I want? I want to find the measurement of this intercepted arc. All right, so I'm looking for this measurement. How far would it be to walk on this arc? Okay, that's what we're looking for. And to find that was denoted by the letter S. Actually, let me write down the formula. S, the length of an intercepted arc, is the radius times theta, where theta was measured in radians. All right? Because radians were specifically what? How far around the circle a single radius would reach if you were following that circular path. Something like that is what you might think perhaps about it. So this would be 14 times 5 pi over 12. So that would be 7 times 5 pi over, let's see, because 14 and 12, 6. So that would be 35 pi over 6 measured in centimeters, because this is a distance, not an angle anymore. And then you could calculate the of that decimal value 35 pi divided by 6, and I get 18.32560 centimeters. Right? And that's the length around that portion of the arc. Not too bad. And then what? Did you guys have a question on... just to point out, problem 39, given in terms of degrees, this formula would not work. So the first thing you'd have to do is multiply that by pi over 180 to convert it to radians.
Okay, I think that's what I did. I changed everything into degrees.
Oh, yep. This formula only works when theta is in radian. When theta is rad.
Theta is radical?
No, not that radical.
Oh.
Radian.
Oh.
Yeah, good point.
Radical drop.
Touche. So, and then let's see. Was there another question down here or something? Did you want to do an area of a sector problem? What do you got? What do you got for me? Did we have this word problem thing?
Yeah.
An arc 7.7 meters
But that's
long.
just the same as...
Oh, but here they gave you the arc length and they wanted the diameter. For 45, I think I'm going to do 41, but for 45 real quick, that would have just been the area is equal to 1/2 r squared theta. Wasn't that the formula? So you would just square 7 is 49, divide by 2, and then multiply by pi over 8. And that's how that works. And that formula also only works in radian mode. So if that was your issue last night, now you know why. So here we are. So let's see. Here, the facts they gave us. We know S is equal to 70.7. We know theta is equal to 5 pi over 4. I don't know R, and I don't know the diameter. So the formula, ravioli, give me the formuoli, is S equals R times theta. So I'm going to do 70.7 equals R, which is still unknown to me, times 5 pi over 4. So to solve for R, what do I do?
Divide by 5 pi over 4.
Divide by 5 pi over 4. Stack-o-frac.
That's not one of those on my...
SAT.
Yeah.
You're not legally allowed to speak about the SATs, especially when I'm recording live on the internet.
I didn't say the word.
Exactly.
I didn't say...
The acronym.
Yeah.
So multiply by the recip, and then that sounds like a problem for a calculator. 70.7 times 4 divided by 5 pi in parentheses. And I get 18.0036. And this would be measured in centimeters. Now, they wanted the diameter, and hopefully you guys know that the diameter is equal to 2 times r. Right? So double it.
Double that.
18 times 2, I get 36.0072 centimeters is the diameter of a circle whose arc length of that degree or radian measure was 70.7 meters. Actually, nope, those aren't centimeters, those are meters. Isn't Mater the name of the guy that's in like cars?
Yep.
My name's Mater, like tomato without the happier than a tornado in a trickle car. I've seen that movie once ago.
Congratulations. So anyways, have a good day, Internet. We're going to talk about other stuff in a little bit.